Nearly everything in our daily life is made of chemicals, such as polyester fiber to make clothes, flavors used for cooking, summer insulation materials in the house, and of course, basically everything used to build a vehicle. Millions of chemicals have been industrialized to produce daily necessaries that have become an indispensable part of our lives. But have you considered how much environmental impacts are caused by producing these chemicals, and whether these chemicals are safe enough for around us? My name is Dachuan Zhang, a postdoc at ETH Zurich. My mission is to develop machine learning models to estimate the sustainability and safety of emerging chemicals. To date, more than 250 million chemicals have been designed and registered, representing the increasing efforts that have been devoted to the design of new chemicals to accelerate the sustainable transition. However, their environmental impacts, such as CO2 emissions, remain largely unknown, which hinders the decarbonization efforts of the chemical industry. Life cycle assessment has become a key method for evaluating the environmental impacts of chemical products and processes. However, the implementation of life cycle assessment in the chemical industry has mostly been restricted to only hundreds of common chemicals, owing to the large amount of inventory data needed, which is usually not available at the early design stage. In this project, we aim to use state-of-the-art machine learning techniques to address data deficiencies and develop predictive life cycle assessment models to estimate the environmental impacts and safety concerns of chemicals based on their available information, such as molecular structure and synthesis rules. A simple example would be the relatively higher impacts of the fine chemical in comparison with basic chemicals. The complex molecular structure of fine chemicals usually requires multiple synthesis steps to bond small molecules together. They hence require more energy, which in turn generates more CO2 emissions and increases the global warming impact. Another aspect of this project would be using machine learning to identify potentially greener production processes and synthesis routes to produce individual chemicals. For the same chemical synthesized by different routes, their environmental impacts may be significantly different. For each chemical, what would be the optimal way to produce it, and how much emission reduction would be reached if we replace conventional production processes with greener alternatives? These are also the questions we intend to find out. We hope this project will serve as a starting point for combining life cycle assessment with machine learning approaches to evaluate the sustainability and safety of chemicals in the early design stage, to close data gaps in life cycle assessment and assist in sustainable molecule design and chemical engineering.